In this lecture, we will learn about collision detection and physics in the Panda 3D game engine. Collision detection and physics are two big topics in game development. Anytime we want to check if two objects have collided in the program or add any sort of real-life physics to our game, we will need an in-depth understanding of how the game engine we are using handles these topics. For this example, we will have a ball that bounces on a trampoline. Not only will this give us an understanding of collision detection in Panda 3D, but we will get exposed to working with object physics using velocity. Up at the top of the code, we will type from direct.showbase.showbase import showbase, from panda3d.core import star, and import random. Then we will create a class named myApp that extends the showbase class. Inside of this class, we will implement the init function. Inside of this function, we will call showbase.init and pass in self. Next, we want to position the camera, so we will type self.cam.setPos and pass in 0 as the first argument, -50 as the second argument, and 10 as the third argument. Next, we need to call some functions we have not written yet, but will write after this. We will call self.setUpCollisionDetection. Then we will call self.addSmiley and pass in the string frowny to add a ball with a frowny face on it. And then we will call self.addFloor to add the trampoline to the game. Then we need to add the updateSmiley function to the task manager and pass in the string updateSmiley as the second argument. Let's create a function named setUpCollisionDetection. Inside of this function, we will set base.ctrav equal to a collision traverser object. Then we will call base.ctrav.showCollisions and pass in render. After that, we will type self.notifier and set it equal to a collision handler event object. Next, we will type self.notifier.addInPattern and pass in the string %fn-in-%in. What does this mean? %fn is the from node, in means when the two objects enter collision, and %in stands for the IntoObjects node. So we are telling Panda 3D to check when the from object collides into another object. Finally, we will call self.accept and pass in the string smiley and floor as the first argument, and self.onCollision as the second argument. The next function we will write is our addSmiley function that takes in two parameters, self and name. Inside of this function, we will set self.smiley equal to loader.loadModel with name passed in. We do this so that we can specify the name of the model we want to load when we call this function, because at different points in the program we will be loading either the frowny or smiley models, both of which are default models that come with Panda 3D and are stored inside of the models subdirectory of the Panda 3D folder. Then we will type self.smiley.reparent2 and pass in render. After that, we will type self.smiley.setPos and pass in 0 as the first argument, 0 as the second argument, and 10 as the third argument. Next, we will call self.smiley.setPythonTag and pass in the string velocity as the first argument and 0 as the second argument. After that, we will create a variable named col and set it equal to self.smiley.attachNewNode and pass in a collision node object with the name smiley passed in. Then we will type col.node.addSolid and pass in a collision sphere object with 0 passed in as the first argument, 0 passed in as the second argument, 0 passed in as the third argument, and 1.1 passed in as the fourth argument. After that, we will call col.show to show the collision node, which is hidden by default. I am doing this so that it looks like the smiley face is a ball that is bouncing on the trampoline. Finally, we will type base.ctrav.addCollider and pass in col as the first argument, and self.notifier as the second argument. Next, we will create a function named addFloor, responsible for adding the trampoline to our scene. We will create a variable named floor and set it equal to render.attachNewNode with a collision node object with the string floor passed in. Then we will type floor.node.addSolid and pass in a collision plane object with a plane passed in, with a vector 3 passed in with 0 as the first argument, 0 as the second argument, and 1 as the third argument, and a point 3 with the values 0, 0, and 0. Finally, we will call floor.show to show the trampoline in our game. The next step is to implement the onCollision function that takes in two parameters, self and entry. Note that whatever function you specify to handle a collision needs to take in the self parameter and one additional parameter, such as entry, or the code will not work. Inside of this function, we will create a variable named vel and set it equal to random.uniform with 0.01 passed in as the first argument and 0.2 passed in as the second argument. Then we will call self.smiley.removeNode. This is because now that the frowny face has collided with the trampoline, we want to show it as a happy face. Next we will call self.addSmiley and pass in the string smiley to create a smiley face. After that we will type self.smiley.setPythonTag and pass in the string velocity as the first argument and vel as the second argument. Next we will define an updateSmiley function that takes in two parameters, self and task. Inside of this function we will create a variable named velocity and set it equal to self.smiley.getPythonTag and pass in the string velocity. Next we will create a variable named z and set it equal to self.smiley.getz. You might have realized this from code we wrote in past lectures, but the coordinate system in Panda 3D is a little different than most 3D coordinate systems. Usually the x-axis is side to side, y is up and down, and z is depth, close and far. With Panda 3D, z is up and down, and y is for depth. So visualize the coordinate system like this diagram. That is the reason we need the z value here. It will be used when calculating the bounce. Next we will type self.smiley.setz and pass in z plus velocity. After that we will type velocity minus equals 0.001. Then we will call self.smiley.setPythonTag and pass in the string velocity as the first argument and the velocity variable as the second argument. Finally we will return task.cont. Outside of these functions at the bottom of our code, we will create a variable named app and set it equal to a myApp object. Then we will call app.run. When we run the code, notice that the frowny face heads down toward the trampoline. When it hits the trampoline, it gets happy and turns into a smiley face, and then bounces up. Then it keeps bouncing on the trampoline. This example gave you a solid look at collision detection and the physics system in the Panda 3D game engine. In the next lecture, we will learn about pathfinding in the Panda 3D game engine.